Okay, so what is knowledge module? Knowledge module is a code template written in Jython. And uses many APIs. So there are many things internally. It uses sorry, actually I was on mute. It is uses many APIs. Again, those APIs also written in Jython only. So just to give a simple example, even we can create our own knowledge modules, and these are the types of the knowledge modules right now are inbuilt, provided by Oracle Corporation. Uh, Even if you want to customize this knowledge module, which are already available, and still it is possible. But the only thing is, the best practice is that whatever knowledge modules which you are planning to edit, before making any changes, you need to just make a backup or copy. Okay. So if you look at the code which is written here in every system, so there will be because this template has to be applied or rendered on top of a GUI, whatever we are developing. And every design which we do in mapping or whatever components we are going to develop here in the mappings and all that, when you save that code, it is going to be saved in a XML format. Say, yesterday we have created a mapping, and this mapping is going to be saved in a XML format. The moment when I save, and this code is getting saved in the backend in a database in the form of XML. So when you apply this knowledge module, so whenever you run a mapping, uh, and we will be as a mandatory, will be selecting one knowledge module, and these knowledge modules are going to use the XML code which is already available. And that XML code is nothing but your mapping code, and it is going to, by using, there are a lot of APIs developed by the vendors. Whenever these knowledge modules are parsed on top of this XML, and they try to get what is there inside in your XML, that is nothing but your mapping, and then it will generate a code. Say for example, this is the code of knowledge module, and when you look at this is the API. Get table is one API. API is nothing but it is a function written in Jython. So this will go and then try to find out in your XML what is the table name you have and what are the column names you have in that XML. So this APIs will go to your XML, will try to pick up that information and then it will frame a create table statement. Or in case if there is a drop table, say even today in the last session we have seen drop table or a truncate. So you can look at truncate table. So whenever you use the truncate table option in your knowledge module, and this is again a API to get a table from your knowledge mapping, that is from the XML. It is going to get that, it will generate a truncate table statement over here. So this is how knowledge modules will work. And there are different type of categories of knowledge module. The starting one, which we call as a LKM, which is known as loading knowledge module. And then we have IKM, this is known as integration knowledge module. Then we have CKM, check knowledge module. We have JKM, generalized. So these are the different categories of knowledge module. In every category, there are so many types of knowledge module, different varieties of the knowledge module. So what is this knowledge module and when to use what type and what knowledge module does what type of activity? So now first we'll understand. Okay, say for example now I have a requirement to extract data from a particular table. So I have a file here. This file having EMP details. So assume that here we have some employees data. And at the same time I have another file which is DEPP. So total I have two files. Let's say, or you can say this is the XML file and this is a text file. So now objective is these two files I need to join and finally load into one RDBMS table. This is my database RDBMS table. And the result of these two inputs must be joined in this particular table. So now when we are developing the logic, so we already know how to develop a mapping. It is very easy to develop a mapping. So I can just drag these two sources because these are the two sources. I can say these are the sources. And you can just drag these sources into your mapping. And then you can also drag your target. And then graphically we can just link them to join. And then finally we can link to target and you can just run your mapping. This is going to finish, complete your task. But actually speaking, in order to complete, we are developing code graphically, but when we execute the code backend, there should be code generated and that code must be executed in a ELT manner, ELT approach. So this is the reason, since this logic, if you look at this requirement, There is no way I can join these two inputs because they are different heterogeneous. Even both are files also, I cannot join them. Even if I have a file database, or even if I have a database, one is in Oracle and one is in Teradata, so there is no way we can join both of them. So this is the reason. If it is a ETL process, Informatica data stage, we don't have any problem. So Informatica can join both of them directly by bringing them to Informatica server and that way. But whereas in ODI, since it is being ELT, these two inputs first must be dumped into RDBMS table. So typically, where these tables are going to dump, even I can choose any of the database. I can just tell ODI to create or dump this data into any of the RDBMS table. But ideally, this input, this whatever two inputs are there, this must be always dumped into your target database. That is the best scenario. But if you ask me like, can we dump or when we do it anywhere, still it is possible technically, but that is not ideal scenario. You will understand why that is. So currently, assume that this is my Oracle database and I have a target table here. This is a target table. And in order to join these two tables, first of all, I need to dump this data into this database. So to dump this, first of all, we must have two tables. In case if you want to store anything in a database, we need a table. So first we need to create two tables in your database. And these tables are temporary tables. And I'm just calling them as a C dollar, or simply they are the temp tables, temporary. So these two tables must be created first, and then slowly data from these two inputs must be loaded into our table. This data must be loaded here, and this data also must be loaded from here to here. Okay. But now, who is going to do the task? We are not going to create these tables in a ODI, and we are not writing a code to dump data from this one. And you just design your mapping to join them, that's all. And the back end, this activity will be automatically completed by ODI. But for that everything we need a code. And this code is going to be generated by a special type of knowledge modules called LKMs. Always LKMs are responsible for loading data from your actual source to your temporary tables. Always LKMs are responsible for how many LKMs, that you can leave it later. And in order to dump data from your source to temporary tables or work tables or C dollar table, all are same actually. So creation of these work tables and generation of the code to get the data from your your actual source to into your work tables or temporary table, and we have a special category knowledge module which are known as loading knowledge module. So whenever there is a demand or a need or a situation to dump data from source to work or a temporary tables, and always we need a LKM, that is loading knowledge module. Okay, once your LKM completes its task, okay, creation of the table and generation of the code, and once code is generated, execution of your code to dump data into your C dollar. So your EMP data will be present here, and your department data also will be present in the table, and both tables will be RDBMS and also are in the same database. Okay, so now I have these two tables, they must be joined, and then this data finally to be loaded into final target table. So now if you look at the scenario, here we have both sources which are supposed to join, the target where we supposed to load, both tables are present in single database. So if you ask any guy who has a expertise on writing SQL, he can simply write a query, select star from these two tables, okay, and then join it, and then finally load, and that can be done in a simple one line with one query. So here again to do this task, okay, reading of the data from the two tables and then joining them and then finally executing is going to be done by a different type of knowledge module, which is IKM. So here IKM is responsible for joining your inputs which are there in your temporary tables, and then ultimately loading data to your final target. So means here always IKM is responsible for joining your data, not only joining. So in this case I used as a word joining, but typically the IKM name itself integration. So IKM is responsible for transforming your data and then finally loading data to your target table. So in earlier case, okay, we were having our data. So previously the data was not in our database. So LKM will bring data to your temporary table. Once your data brought into your work tables on your target database, and IKMs are responsible for picking up the data from your work tables or temporary tables in this case, and apply any transformation rules, and then finally load into your target table. So if you look at the difference from LKM to IKM, LKM is only responsible for dumping the data from the source to work tables, and it is not expected to do any transformation. So LKM responsibility is only to lift and shift. So take it from the source and dump it, and it is not expected to do any of the transformations, logics. And here IKM is responsible for applying the complete transformation rules. Whatever logics you apply in your ODI, all those logics are to be, for those logics, code to be generated by IKMs here, and ultimately it will load data to your target table. So IKM is responsible for loading data to your final target and apply any transformation rules. If there are no transformation rules, it will not apply any rules, but it will load into target. So in a simple way, LKM always loads to temporary tables or work tables. IKM always loads to your real target table which is there in your mapping. If you look at this is my real target, this is my real source. So intermediately we are getting one more layer, that is your temporary layer. So source to temporary LKM. and from temporary to your final target, that is IKM. And that is the reason integration knowledge module. Integration is transformation. All that activities will be done by IKM and then finally loads into your target. Okay, fine. Okay, say for example, so in this situation, I have a sources here and then I have a target here, fine. So now I have a requirement where I have a simple table. Let's say I have a one table, EMP table. I have a single table, EMP, and that is in my database. So I have a table in Oracle database. That table name is EMP SRC. And this table is already in my Oracle database. And this data I want to load into this target. If you look at my source is already in my database. My target also already in my database and both are in same. The best example is yesterday's our mapping, whatever we have created, we are reading from EMP source table, loading into EMP target table, both are in same database. In this case, we don't need any LKM because we don't have any scope to dump data from your source to work table. Since your source is already in your database, and in this case your IKM can happily pick up data from your source and applies any transformation rules required and then finally loads into your target table. So in this situation where your source and target tables are already present in a same database, in this case we don't need any of the LKMs, and IKM will take the responsibility of reading data from your source and then finally loads into your target. So this is the reason in yesterday's mapping, when we look at, since your source and target already present in the same source, same database, so it is not asking for IKM anywhere. It is just, LKM anywhere. It is just asking for IKM only because we don't need LKM. So that is the reason if you develop a mapping, to execute a mapping, minimum we need one knowledge module, that is IKM, because that is the one who is going to load data to your target. So IKM loads data to target always, but when reading the data, it may read data directly from a source, provided if that source is already in your database. If not, it will read data from the work tables, $C tables or temporary tables. But who will bring the data to work temporary tables? Your IKM is going to perform that activity, and your IKM is responsible for loading data to your temporary table. So that way, both LKM and an IKM combination will work. So right now, if we look at this mapping, we will be requiring only one knowledge module, that is IKM. So minimum one mapping knowledge module needed to execute your mapping, that is IKM. So IKM always loads data to target, but it can read from source directly or it can read data from work tables. And if you look at LKM, always it dumps data from source to temporary. If we don't need this situation, if we are not in this situation, we don't need LKM. If the situation is needed, then LKM and IKM combination will work together. That is a concept. So if you look at, both sources are there in same technology. That is the reason understanding of this diagram is very important. Source and target both are in same database. So immediately we can assume that okay, there is no need of LKM here because both are same. So this is the reason, since there is no need of LKM, so it says that you can move directly from here to here. So the diagram is representing whatever information we need. So when you click on the target here, there is no way you can see a word LKM here. Even if you click any of the option, there is no way it can ask for the LKM because it doesn't need a LKM over here. Okay, fine. So now typically minimum we need one IKM to process. Optionally depends on your sources, we need IKM or LKM. Okay. So now to move on, say for example, most of the times when you are processing the data in a data warehousing, it is very important to validate your data. Okay, say for example, now I am loading data to your target. So during the data load, say for example, I want to validate some data. Say for example, I am loading some data to target. Say now in my source, I have some employee number and then employee name. And this data is coming from a file or source, whatever it is. But when I am loading data to target, in target, employee number is primary key. So when I am loading the data, so I have some duplicates in employee number column. So when I load, definitely it will fail. Or I have some null in employee number. So there might be lot of data validation rules to be applied when you are processing the data onto target. Otherwise, if you have bad data in your warehouse or in target, it is useless. So having some, like it is like a simple example, you have some $1 billion to buy any food and then eat, but you are a sugar patient. So here also in data warehousing, it is not that like how much data you have, but how much clean data you have. That is very important. So that is the reason we take utmost care when you are processing the data to have like more qualitative data. So having invalid data, it is useless. It is unwantedly occupy space and then will give you wrong analytics that may lead you to the bad business decision, that may lead to the different business major issues. So this is the reason validation is very important here. So that is the reason whenever you are thinking about or expecting about validating the data before you are loading to target. If you are not looking for the data validation, you can simply ignore. But at the moment when you think about validating your data before going to load data into your target, okay, so your IKM is going to apply some transformation rules and then loading data to target. But in between, once IKM applies the transformation rules and before going to load data into your target, if you want to validate your data, here we have a special type of knowledge module that is called CKM, that we just now discussed about, that is a check knowledge module. The CKM is always responsible for in between when you are processing your data. So IKM always integrates and loads data to target. But in between, in case if you are looking for data validations, you can happily choose. Let me put it. So it will not work independently, and always it will work together with IKM, because the validation always must be done in between your transformation and then your load. Say IKM, if you take from year to year, it is processing the transformations because it requires two kind of activities. So after transformations, and before loading, so let's say we need a code for both of them. In between, if you choose data validation, then your CKM is going to come into picture and it will identify all the bad data what is there in your tables. And how does it identify? So we need to provide the rules to identify which is the bad data, and then CKM will automatically identify those bad records. Then it is going to load or place those bad data into a different set of table which is called error table. This name can be anything, but this is error table. And also it can also provide statistics also, how many number of records errored out and all that. And it can also it can also help to reprocess the data, and that is the beauty of the even these error records also further can be reprocessed automatically. The same thing if you want to do in other tools, we need to spend a lot of time in writing the code. But here very simple, if you just define the rule and as per the rules, your CKM is going to take all the bad records and put it into error table along with the statistics with error messages and everything. And it can also support the reprocessing these bad records in the next day, provided if you have corrections and all that. Anyway, there are lot of conditions apply, rules to be defined for reprocessing, and but it has the ability to reprocess. And finally, ultimately, only good records are loaded to your target, and always bad records are loaded into error table. So that way, in minimum, these three knowledge modules are mandatory when you are working on any data version file. You are LKM and IKM and then CKM. So always LKM and CKM are optional, they are not mandatory, but IKM is mandatory in any of the mapping. So without a IKM, we cannot execute our mapping, because this is the one in the worst case scenario, if you are not doing, if you develop a very simple mapping, no data dumping to temporary table, no validation required. So minimum to operate this, we need a single knowledge module, that is IKM. But if you are looking validation, CKM. If you are looking, if your data is outside your target, then we need a LKM. So that way, they all keep getting added, depends on your requirement. So this is the reason in yesterday's mapping, I have not opted for data validation, and because this knowledge module is not capable of performing the validation or invoking the CKM. So that is the reason I have not opted, and also I have not even selected the CKM also. So in this case, there is no validation. So whenever you want to invoke CKM, first you have to inform IKM that I need to do validation. Then only it will expect CKM. Otherwise, it doesn't know. Okay, so there are certain things to be configured. Anyway, that will be learning in a technology or classes. So the overall, these are the three very critical knowledge modules. Without them, generally we don't work on any project. So then other knowledge modules are there, JKM, okay, which supports generalized knowledge module. in case you are planning to get your data from other CDC tools like Golden Gate or like in Informatica Power Exchange or any, the static and flow control will be part of CKM. And when you are doing the data validation in the CKM, uh, flow control will validate the data before your data goes into target. Means generally whatever diagram is there, and this is actually flow control. So it will prevent your bad data going to your target. That is a flow control. Anyway, in the CKM topic, I'll go detailed. Whereas static control, it allows your data, means it will not validate data before loading to target. Once your data loaded to target, then it will perform the validation. So in case you have any constraints on your target table which may cause failure of mapping, then it will still fail your mapping. But if there are no constraints, it will still accept your bad data. But after completion of the loading, your static control is going to validate your data, and then it will give you what are those bad records and keep them in the error table, but it will not delete them from the error table. So there will be certain scenarios. Generally, static control does the data profiling. It will not clean up bad data from your table. It will only give a information that this is the bad data you have. So mostly we will use static control in a data profiling. You can go to any table, right click, and then do the check validation. That is the CKM validation that does the static control only. I'll go detailed on the CKM topics. But overall, in a simple one-liner definition is, flow will validate your data before loading, means while data is flowing to target. So that way your bad will not go to target. Whereas static, it does the validation on existing data. In other way, after loading the data or existing data, and it will provide a report of what is your bad content, but it will not delete the data. That is the difference. Anyway, I will practically see them in a CKM classes. And then the JKM is just meant for CDC purpose. It supports both external CDC tool data capturing incrementally, and it also supports internal trigger based CDC mechanism which is supported by ODA. RKM supports customized reverse engineering in case you are planning to get data from different technologies where ODI is not provided in a standard way. So we have special knowledge modules for them. Then SKM, if you are working on a web services and those. So these are all completely optional. So mostly this may sometimes you may use in case you are going with incremental, and these two are purely on a need basis, and they are all just for using additional reverse engineering knowledge modules and using web services. In case you are working on a web services, and this SKM knowledge modules are specially designed for your technology, will be using them. So, but mostly these are the three very critical knowledge modules we generally use in the project development. And additionally, we may use or take the support of these in case different things are coming. So one is for CDC, change data capture, incremental data extraction, and this is for the reverse engineering. So this is the whole concept of knowledge module. And tomorrow we'll be starting with the components, the practical development of the components. And during the components, we will be talking about various knowledge modules, and we have a step-by-step process to learn each of them. But we'll cover everything, and I'll go in a flow one by one. Okay, so that is all about the knowledge modules.